Hey, folks. How's it going? Gotta update the stream title. There we go. I hope everyone's doing very well. Having a great Wednesday. Today we're jumping into something new. We're no longer doing the compiler optimizations. Instead, we're going to jump into AOT compilation. Let me come up with a plan here, because this is going to be some new territory. So I'll get more into explaining exactly how this is going to work. But let's... So we're going to want to... maybe static runtime. And in the static runtime, we're not going to link. For Clojure JVM, I never use AOT. Will this be different for jank? Hey, DJ Blue. I think that it's odd that you never use AOT compilation for Clojure JVM, DJ Blue. Because when I was like doing Clojure professionally, I definitely used AOT. You're not the weird one, because I think I'm the weird one, because I remember at last conj. Wait, you were there last conj. Do you remember the whole discussion when we did the tooling circle? And I was saying how, we make, like, Uber jars are really difficult to make, and Rich Hickey was like, I don't do that. People shouldn't be doing that. And I think it was Pez, Peter Stromberg, who was like, yeah, I don't think I've ever made an Uber jar. And Rich Hickey got up and shook his hand. So I'm the odd one out. You've built plenty of Uber jars, but you just put your source in them. Why not AOT compile? I don't know what. Yeah. I don't know. I always just AOT compile those to get class files, and they're going to be faster, faster load, everything like that. Especially like services, whatever. I just want them to start up faster, so I just AOT compile. Anyway, so for jank, we have a lot of options, and I was just noting all of this down in a document here. So for jank, we have the ability to, and unfortunately static is used in a bunch of different ways. So we have, I will just say in general, for native, AOT compilation makes a lot of sense. I'm coming at this from a C++ perspective. And from a C++ perspective, AOT absolutely makes a lot of sense. Now, DJ Blue, how the C++ like JIT compilation times are, right? And so if you're just starting up your, let's say you build a service in jank, if you're just doing a jank run 03 to start up your service, you're going to need to recompile your whole service every time you start up. And that's just kind of silly. So AOT compilation is going to allow you to just turn that into one executable. Also, if you want to, so native is a lot more difficult than the JVM when it comes to distribution. With the JVM, you can just distribute an Uber jar full of your source files, and then you just do a java-jar, and then you're off to the races. But with a native application, you have all of your compile time dependencies and everything like that. So if you're just doing a Java run, if you're doing a jank run, which is effectively going to be your java-jar, if you're just doing a jank run, then you're going to need all of those compile time dependencies that you have for your code as well. Which means that if you want to, let's say you're developing a service on your machine, and that service uses Boost ASIO, and it uses like, I don't know, some JSON parsing library and everything like that. You'll need to have all of those available when you're developing, but also when you publish that to your server, wherever that's going to be running. You're going to need to have those available. So maybe they're bundled up in a jar, or maybe they're installed on the machine. Or maybe they're just, sent alongside on the disk. But either way, they need to be available, and then they need to all be compiled. And it's just a lot. It's a lot more to worry about. And like C++ is just a lot less portable than Java in that regard. And in the sense of like not needing to worry about it just working on another machine. Java, for the most part, will just work on another machine. C++, the default is not going to be, it'll just work. The default is going to be like, yeah, we'll probably, we'll see. And if it just works, then that's like it's two things. One, it's like a sigh of relief, and two, it's like what's actually broken, like no way this works first time, right? Can jank search jars for CBP and HBP files? We do this for jank modules. If you try to require a module that's backed by a CBP file, then we'll find the corresponding .cpp if it exists. But we don't do this for pound includes. We would need to. Yeah, we could potentially do that. We would need to register all of those jar files with like, or all of the headers and CVP source files inside of jars with like Clang's virtual file system. Maybe we can maybe that makes sense. But the thing is, I don't want people to be packaging C++ source along with their Uber jars. I just don't think that's, I don't think that makes sense. I think, and that's just because let's say you package all the sources that are needed. If you just try to compile that on a different machine, you don't know what's gonna break, what's not gonna break. It's not gonna be a perfectly reproduced environment from what your dev machine was like. So I think AOT compilation is just the better move for that. But for AOT compilation, you're going to have a lot of options. So the thing that we're going to tackle today, the thing that we're going to start tackling, because I don't imagine we're going to finish this. The thing we're going to start tackling is the ability to have a static runtime. And so jank is going to have a few different sort of levers, right? So we're going to have a runtime. You're going to have either a dynamic or a static runtime. And so a dynamic runtime, it links to Clang, LLVM, which I'm just going to call LLVM because Clang is part of LLVM. It makes it easier for me. So it links to LLVM, and has to initialize, and it has full JIT capabilities. So if you need to, this is basically your Uber jar. If you do a java-jar, then you'll get your whole application. Let's assume it's an Uber jar with AOT compiled class files in it, not source files. Then at that point, you have the whole JVM still. You can still like JIT compile whatever you want after you start your application up. But it's also just packaged into an executable for you instead of an Uber jar. Now the static runtime, this is like a GraalVM native image. And so this does not link to LLVM. And it has no JIT capabilities. And so everything is going to be baked down in the static runtime. This is going to mean faster startup, and also like smaller binaries, because we're going to be able to do like link time optimization and dead code removal, all the goodies. And this will also be faster just in general faster, because we don't have a JIT optimizer like the JVM does. With the JVM, when you compile your application to a Graal native image, you get a faster startup time, but you actually sacrifice speed in the long run. And so it's great for like compiled command line applications that just like quickly start up, do some work, and then they're gone. But if you're doing this for like a long running service, then it doesn't make as much sense for the JVM. But for jank, we don't have a JIT optimizer. And so as fast as jank is as fast as it's going to be. And so if you do a static runtime, we're going to be able to make things even faster, because we're going to be able to do like whole program like inter procedure optimizations and inlining, everything like that, statically, at compile time or link time. And then you're just going to end up with a faster binary. Smaller, faster. So these are the two options for the runtime. And then the default should be static, I think. And that's just going to be like a C++, like a normal C++ application, which has, this is all of my behavior of my application baked down into an executable. And you just like, it's easier to distribute because it may dynamically link to some things like system libraries, but it's not going to dynamically link to LLVM or anything like that, because there's not going to be any LLVM there. But if you have the need, like if it's a requirement for you to be able to JIT compile more stuff at runtime during your application, if you need to call closure core eval or something like that, then you can use the dynamic runtime. But you'll have to pay the startup cost of initializing the whole LLVM JIT runtime, and you'll also have to pay like the performance cost of needing to JIT compile this stuff. You'll need to pay the cost for the disk space cost of like needing to actually link to LLVM and have the precompiled header baked into the executable and everything like that. So like these binaries will end up being a lot larger, and they'll start up slower, and they will probably end up running. Well, that one will be harder, but probably slower, marginally slower. That's the first lever. The second lever is when you're linking LLVM. So this is for a dynamic runtime. you can either link statically or you can link dynamically. And so this actually embeds LLVM into the executable and then stores LLVM separately. So if you statically link LLVM, and this should be the default for the dynamic runtime, it's just going to be easier to redistribute your application because it's going to have everything you need right there. Now, that's not to say it's a statically linked executable. It's just the LLVM is statically linked. And if you choose to link LLVM dynamically, you can. But then when you distribute your executable, you're going to have to distribute LLVM along with it. Unfortunately, we can't actually rely on system packages to like distro packages to handle this for us because LLVM has new releases every 6 months and they break the API of whatever they want every 6 months. So this means that jank has to ship with its own LLVM. And if you make an application with jank, and you want to distribute that out for people to use, you really need to like ship the LLVM that application is using along with the executable. I think the easiest way to do that is to just statically link it, which is why this is going to be our default. I should swap the order of these, that way I can just say like this is default and this is default. And that way, if you ship an application that you've written in jank, it will continue to work after the distro that your users are using updates their LLVM to the next version, and that breaks a bunch of stuff. Your application will keep working because it's statically linking to LLVM. This can work for some cases, but I don't think is going to be what people want. And then finally, there's the actual executable linkage, which is you can either have a dynamically linked executable or a statically linked executable. And that is just a native thing for whether or not your executable. So if we take a look at like build jank, so this executable is clearly dynamic. We could see that when we just do this. That's a symbolic link. So we'll see here, like this is dynamically linked, and we get to see here all the libraries that we're linking to. So right now, like jank dynamically links to LLVM because it ships LLVM alongside it. But jank compiled applications, what we're going to want is we're going to want those to be statically linking to LLVM. But they'll still, by default, be dynamically linking to like system libraries like libc. Static executables have everything that they need baked into one executable, including libc and everything like that. But it comes with some downsides that I'm not going to go into right now. So these are the knobs that we're gonna have, and this is gonna be the default. And my goal here is to just choose sane defaults because most Clojure devs are not gonna understand all of the implications of these. Like I'll document all of these in the jank book and everything like that, but most Clojure devs aren't really gonna get it. Most C++ devs, they'll get these two, but they'll need to read up on the static and dynamic runtime because that's a jank concept. Yeah, no need for apologies there, DJ Blue. It's a relevant question to what we're actually doing. I'm gonna turn my fan on. All right, so what we're gonna do today is we're gonna get started on this static runtime. And the way that this works is jank has a static library called libjank standalone. And libjank standalone has it has libjank, but it also has all of the other dependencies like folly and zip and nanobench, and they're all just sort of packaged together in one archive. What we want to end up doing is we want to make another static library. And this is confusing because this is a static library, but that doesn't mean it's a static runtime. It's just a static library. What we want to do is we want to make another static library called like libjank standalone, I don't know, static or something. Like maybe we'll change the name of this one, but we're going to want to have two versions of libjank standalone. One is going to be the dynamic runtime. One is going to be a static runtime. And the static runtime is not going to link to LLVM at all. And that means that when we go through our code, and we're going to have to go through the whole jank compiler and runtime, we're going to have to conditionally compile out all of the uses of LLVM to make sure that when we compile with jank static runtime defined, that we don't include any of that code. This is going to allow us to build that without linking to LLVM, which is then going to set the stage for us to be able to like have our AOT process use this library instead. So this is going to be like a, let's call it libjank standalone static runtime, probably. And then this will be dynamic. I think I'll probably call them this. That way it's just super clear what's what. And let me yoink all this actually, and I'm just gonna put it here so I don't lose it, because that's useful. That's useful. So the process for this is gonna be rather than dealing with making a whole new static library right now and then having to compile both, I'm just going to update the current one, and we're just going to try to get it compiling and linking without LLVM. So let's do that. What I want to do is common, yeah. So I'm just going to like define right here, jank static runtime is what I called it. Okay, so normally, like once we go forward, this is only going to be defined when we're compiling libjank for the standard for the static runtime. And so basically, what we'll do is we'll end up compiling libjank twice. And that's going to be annoying during development, so we're going to change it so that way it only happens probably by default with release builds. And then if you want it for a debug build, you can enable it with a flag, because you're going to have, it's going to double our compilation time pretty much. Hey, Twitch GD, how's it going? So we're going to define that here just to start with. You're adding a static runtime for jank? I am. Yeah, I'm adding the ability for us to basically do a Graal native image type thing where you can, when you're AOT compiling a jank application, we're going to be able to just bake it down to something that doesn't depend on LLVM. But in order to do that, we have to get a version of jank that doesn't depend on LLVM. And then that's what we're going to be building our, or that's what we're going to be linking into our AOT binaries. Okay, so we're going to do that. And then what we want to do is we want to find our We want to find our, this is jank hook LLVM. Definitions, directories. Where are we actually linking LLVM? Because I just want to remove that. I don't know if this is done for us. This is our janklib standalone deps. We don't have LLVM here because that should be part of the executable. Here's our janklib. And we're not going to have it here. But when we get to jank exe phase 1, LLVM and clang CPP. That's the one right there. So let's disable this. So what I've done is I've disabled the linking of LLVM and clang CPP. And so we're just going to, we should be able to build everything. Let's disable test for now. We should be able to compile everything, but we're going to end up with a lot of linker errors. And that's to be expected. I could change the includes, like the include paths, so that we can't even include LLVM headers, but there are some like header only stuff that is going to be useful to have. And also I think it's just going to be a lot messier to try to like completely isolate them at the compilation level. So we'll just do this at the linking level instead. So yeah, I expect all of this to compile, and then when we try to link jank phase 1, that's when we're going to end up with probably a fuck ton of undefined references. Now, while that's building, I'm just going to jump into places where I know that we already need to handle this and then start handling it. So this JIT processor is the jank code that wraps the whole like LLVM JIT runtime. So what do we want to do with this guy? Hey, NFA 13. Welcome to the stream. Hope you're doing great. NFA 13. So I wonder if I want to have a separate version of this file where we will conditionally compile. If we have a dynamic runtime, we'll just use this file. And if we have a static runtime, then we'll just bring in a different version of this file, like that defines JIT processor in a different way. That's one possibility. Another possibility is that we just do all of this using preprocessor checks. Let's take a look at our headers. We got a bunch of functions here. And none of this stuff matters for a static runtime. But the problem is if I break the API for the static runtime, then all the code that's calling this then that will fail to compile. I'm just wondering how we want to handle this, because like one way we could do this is I could just change the implementation in the C++ file, in the CPP file, to if we have a static runtime, to just provide an implementation of each of these functions that just throws and says, yep, can't load this IR module because we have a static runtime. And then just count on those functions not being called. But another option is to just remove them entirely. So that way I would say like, yeah, well, we would say like, if not def, jank static runtime. So if you have a static, if you don't have a static runtime, then you have all this. If you do have a static runtime, then these just don't even exist. I don't know what that's going to break if we do something like this. I do like the idea of this though, because I would want the static runtimes to be as small as possible, right? I'd rather not have all of these functions exist and then have them have some actual code in there that throws that we never expect to be called, because I want the binaries to be as small as possible. So I'm going to lean toward seeing what we can do with this style. Okay, so this finished compiling, and then as I said, we just have a fuck ton of undefined references, right? So we're just going to have oodles of noodles of these undefined references to LLVM stuff, right? Debug flag, current debug type, debug, blah, blah, blah. And that's expected. But let's not worry about that, because we're going to, when we make this change, we're going to end up breaking some compilation stuff. Like so. So module loader is trying to find symbols. Let's take a look at this. That was 1135. Great year. So this whole load O function could go away for a static runtime. Like loading jank, loading files in general is not like this whole module loader can kind of go for the static runtime. So I think maybe we try to do the same thing as we did with the JIT processor, and let's just like boldly disable all of this. So that's in the header, and that's going to break some other shit. And so this starts with read file. Whoops. So this goes all the way to the bottom. And if, and then this ends with to runtime data. Yeah, to runtime data word. Okay. That's going to cause more failures. Let's take a look at what we have here. Runtime context is using the interpreter in 259. So this is where we are doing an eval. And so we have this eval file, eval string, eval CBP string, all this stuff. Read string we can keep. Because read string is just parsing. But if we take all the eval, probably not that, eval file, eval string, and then there's this separate eval here. I'll bring that up here. So this guy, I'm going to move up to, I put it under eval CBP string here. And then we'll do an endif here, and then it was right above eval file. Yeah. All right. What's this? I'm not going to look at those because I think all those have already been handled by the work I just did. And we're just going to handle these like as they come, because they're just going to be a bunch of these. Maybe we should even just simplify this down. Let's do one at a time. Or maybe not, because that's too slow. There you go. Now it's twice as fast. So we were looking at CAPI has eval. CAPI has eval. Right. So we'll say if and def jank and if and then 1019 it was doing module stuff. I think we need this add load function set is loaded stuff. So here's set is loaded. And add load function. I think we need these. I think that they're used by Is that right? Because when we have a AOT binary, we still end up having to load modules, but we just don't load them from source. We register these load functions that are baked into the executable. And we just say, okay, so when you go try to load module foo, call this function. And that's gonna do the load for you. So that's why we shouldn't need, yeah, maybe we're gonna need to add this general load, but we'll see. I'm trying to start as like, I'm trying to remove as much as we can and then only add things in as needed. So is loaded, set is loaded, and add load function. So we'll grab is loaded, we'll grab set is loaded, and we'll bring those up above this. And then add load function, and we'll bring that guy up as well. Okay, so that'll handle both of those. Right. So here we have Klang's virtual file system, and also we're trying to get the LLVM runtime here. So this is inside of util Klang. Let's take a look at that. And that was 241. So this whole find PCH stuff, like none of this stuff is gonna matter. The whole like precompiled header, we're not gonna need at all. So find PCH, build PCH, target triple, find Klang, invoke Klang, none of this stuff should matter. Hey Johnny, how's it going? None of this stuff should matter. Algae, nice. So yeah, I'm just gonna do a if and def jank and if and def jank runtime and if. That's gonna cause some other things to break that are using this. That's fine. Error report. .476. Okay, so our error reporting has code snippets. That then read files. I don't know yet if we want this for AOT, for the static runtime. I'm gonna say no. I'm gonna default to no again. So I think this whole thing, I'm gonna do one of these, if and def jank static runtime. Got a sneeze coming on. And if, and then I'm gonna grab this. I'm gonna provide a different implementation of this. Not end if. Else. End if. And then here we're gonna do basically the same thing as what we're doing here. Error, yellow, red, and then E message. Yeah, so for the static runtime, if we need to like report one of these errors, we're just gonna output this error message here rather than like grabbing the code snippet and everything like that. I don't know if we're gonna want all this fancy stuff for those cases. We'll have to see. We could always add it in if we do want that. Reparsing. So reparsing is something that we do when we try to get better source info for errors. We should not need reparsing at all. Where are we using reparsing? Analysis is going to use reparsing. So we're going to want to provide different implementations of these. So we have these three functions that are part of the public API for this. And I am just going to return source unknown for all of these. And so we'll grab that, and then we're just going to delete this and this and this, and then also this and this. Is that a function? That is a function. Okay. Module loader 655. Okay, yeah, so this is general finding of modules. This is from read jar file though. Do we need this? I don't think so. We should not need to read jar files. Yeah, so we're gonna move this guy. This is map file as well. Yeah. Is it really hacking if it's your own compiler? Yes, absolutely. What are you talking about? What do you think hacking means? Serious question. Define it for me if you're interested. 252. Oh, we're not going to need any of this. Too addicted to compilers, couldn't help yourself? CLJRS, cool. Jank-like impl of closure top of Rust. Transpiling to Rust. So do you have JIT compilation in that, Johnny? Binary version. We don't need any of this stuff. We use Rust C and DLLs. Slow as hell. Yeah. And then what about interop? Are you able to do Rust interop from the closure code? Because that would require hooking into the Rust compilers like AST or some sort of compiler as a library. We could probably disable all this stuff. Ben Chilling, one of the things I've talked about in a previous stream is these how to become a hacker, is like how I got started. And there's this cat B. There's this great website which unfortunately doesn't have a TLS certificate right now. But there's this great website, came up around 2007, which is when I started reading it, about how to become a hacker, and this defines what a hacker is and sort of what the mentality is, and basically the hacker mentality is just a way of approaching life. And in particular, you know, we use it during software development, but it's a whole philosophy. And so can I hack on my own compiler? Fuck yeah, I can. Like, the idea of hacking is, you know, how I approach the development. I don't think we need any of this. Module version, binary version, verify binary version, core modules. All right, might need these. Normies don't know that second definition of hacker. Arguably, it's the first definition of hacker, not the second one. Because that's what, like, the hacker term originated with that. The hacker term didn't originate with like malicious hacking, right? So we can move this, all this zip stuff. What is, yeah, this is just core stuff. So we can move all of this. Grab this, register entry. Don't need that. Register directory, register jar, register path. How to become a hacker with no TLS? Ironic. Yeah, I mean, to be fair, the guy who wrote it is like very old now and suffers from, I think, some pretty severe illnesses. So I don't really fault him for not keeping up on that website. Okay, this is this. Do all this and then register module path. So we'll just do it. Hook that in there. What's this file view stuff? That's this. Do we actually use file view anywhere in here now? This is all defining stuff. File view, no, that's all removed. No, that's all removed. Okay. I think that this file view, file entry stuff can also go. Let's grab this. Whoops. Grab this. File view, operator view. This last thing is reset. Yeah, we'll do that. And then we'll bring that here. And then that's file entry, file view. Loader 161. Yeah, do we need this? No. Do we need this? It is here. Yeah, that gets hairy. Yeah, this file, because there are some bits that we want and some bits that we don't want, ends up getting messier. I think what I'll do for this is that I will keep these. Java is such a wonderful platform for implementing programming languages, full access to everything at compile time with reflection, safety guarantees, GC object model. If you're into that sort of thing, there are benefits, but I wouldn't want to write Java. Like, there are plenty of drawbacks to C++, and I would choose Rust over C++ for a lot of things, but I would choose either of them over Java for most things as well. JVM, not Java? Maybe, but I haven't actually used a language on the JVM. I haven't used imperative or object-oriented programming language on the JVM that I've really liked. I haven't used Kotlin though, so maybe that would be the one that I like. But I have used Scala. I've used EDA or EDA. I don't know how it's pronounced. The Haskell-like on the JVM. Yeah, maybe Kotlin. Okay, so runtime context. We don't have read file. Yes. Do we need, so what's runtime context? Runtime context 487, I think it was. 486. Read file. Right. Isn't Scala enough Haskell-like? I don't think that the Haskell folks would say so. Scala is one of the worst languages I've ever used. I don't know if that's just because of Scala or if that was because of Akka, the library I was using it with, but it was the most magical, like dependency injection oriented code I'd ever seen. It was awful. Well, if you said Clojure is functional almost like Haskell, a lot of people get angry. Yeah, I wouldn't say that. Yeah, I know those. I know the Haskell folks are they're always looking out. Let's just remove read file for now. So we also have 484 and 649. We don't have the target triple. Why do we need that? Because we're writing a module. We don't need module writing. We don't need compile module. We don't need, I don't know if we need load module, but we don't need compile module. We don't need write module. Uh, 544. Yeah. I don't know if we need this. I think we might. So we'll go to loader. I think it's just called load. JVM already has everything you need to implement a language. Well, I mean, sure, any Turing complete language has everything you need to implement a language. Ruby has everything you need to implement a language. Lua has everything you need to implement a language. Python has everything you need to implement a language. But you're not arguing for those, right? Why not? And the answer generally is like, well, I don't prefer those. And so what we arrive at is that like this is the common thing that people do where software engineering tools are not measured simply based on their technical merit, because we have so many different options that all have various technical merit, but they're all like effectively capable of doing the job. An honest answer, well, I don't write Ruby. Exactly, right? Does that mean that Ruby's any less suitable than JVM? No, maybe it's even more suitable, but you don't even know, right? So this is the whole like opinionated side of software engineering. And the reason why this exists, I proposed a talk for Clojure Conj exactly on this topic. The reason why this exists is that there's a scientific side of software engineering, which is just like the practical engineering side, where engineering is the application of scientific knowledge. And then there's a whole art side of this as well. And the art side is more subjective, and it's more stylistic, and it's more personal. And so an engineer can look at this and say, okay, well, Ruby can be used to build languages. Lua can be used to build languages. Why would you use the JVM? But from a personal side, like a human-oriented side, a subjective side, we have tools that we like, and we say, oh, well, Clojure is great because it, philosophically, I like how it makes me approach software, and I like the community that's behind it, and I like the the talks that Rick Schickey gave and blah, blah, blah. Like, that doesn't mean it's technically more competent at completing certain tasks. I could write all of the same shit in C if I wanted to. I could write it in assembly if I wanted to. And there's nothing wrong with that, but it's important to keep in mind. Because someone might say, like you, Johnny, oh, well, JVM can do all this stuff. Why not just use the JVM? But, well, a lot of shit can do all that's required. So we don't have eval string and deferred CVP function. Do we need deferred CVP function at all? No. We shouldn't need any of this. So the analyzer is reaching into the JIT processor to be able to grab the current diagnostics. 3798. Ah. Maybe we can just get rid of this whole analyzer for these builds, but that's going to be a much bigger thing to yoink out, so we'll not worry about that just yet. CPP util is reaching into to JIT compile stuff. Similarly, this whole thing we should not need. This whole file. But it's going to be messier to pull out. All of these are reaching into the Clang JIT environment. This is going to be, yeah, this will be a pain in the ass to pull out. We'd have to do the whole analyzer. But we should anyway, because we're just not going to need that analyzer. I don't know how to read this one. Could be Ngang. Akamau could be Nganja. But welcome to the stream. Hope you're doing great. Probably not going to Euro closure. I am. I do plan on going to Euro closure. I'd like to give a talk there. In Prague. Check out what Prague's like. We'll meet in real life then. Yeah, looking forward to it. That's your hometown? Oh, cool. Yeah, let's just try to do this whole thing. See what kind of trouble we get into. We're down to just what, 15? I think 2 of those jobs are not actually translation units. Do they pay for the tickets or not really? It's kind of expensive, I suppose. If you're presenting, yeah. So, like, I think I'll only be going to Euroclosure if I have a talk that's accepted. But if I do, then they'll pay for my ticket as well as my hotel as well as my flight over generally. Okay, evaluate. So that is an expected one. We don't need, this is for evaling AST expressions. We should not need this at all. If and def. But yeah, if I don't have a talk accepted, then I have to pay the flight and hotel and tickets out of pocket, which is not going to happen. Not with my income. Okay, so now we're on to the AOT processor. What's this? Chip processor stuff? Okay, let's take a look at this first. Chip processor 98. Uh-huh. Yeah, we ended up just disabling basically all this, right? Yeah. So what I'm going to do is I'm just going to do if and def on this. I'm going to grab all that. I'm going to do an else here. And then I'm going to do this. And then I'm going to... Oh, we really just have this, don't we? That's in jank JIT. I think we just won't do anything with that. We're going to need an include here for jank JIT processor H. Hey, Mr. Mugame, welcome. Or Mr. Mugame, depending on how either like Japanese or Spanish speaking you are. Core native. $274. Yeah, so is this used at all? No. We just get rid of that. Okay, so now we're into AOT processor land, and we are, yeah, we're getting there. So no fine PCH. So this whole AOT processor can just go because your AOT compiled binaries, this is the kind of mindfucky part about it. But AOT compiled binaries just don't need to be able to AOT compile binaries because they're, especially static runtime AOT compile binaries don't need to be able to AOT compile binaries. So this whole thing can just go. What am I working on right now? So Johnny, I'm working on the ability, I'm working on a static runtime for jank. And this is going to allow us to use the jank compiler to AOT compile jank applications to target this static runtime, which is basically going to be, it's going to allow you to compile jank programs down to an executable that does not depend on LLVM anymore. And so it's the equivalent of like a Graal native image. Clojure Core eval uses Clojure Core native. Yeah, I was wondering if that was the case, DJ Blue, but I don't see why we wouldn't just... I guess we'll handle that when we come to it. But no reason that we can't just be calling into the runtime context for that as well. Like that whole core native namespace is old news. Like it needs to go. It's just kind of lingering like a bad fart. I've been ripping out pieces of it. No eval file in main. Nice. We're down in main. That's great. Okay, yeah. So we can't... I mean, we're not going to have main at all. Main is only showing up here because we're compiling... Or like these issues are only showing up in main because we're compiling. Yeah. So like I'll work around it, but this won't actually be a problem in our normal case. If you want to compile to an executable, you have to make sure that the code doesn't depend on functions such as read string, eval, macro expand. No, that's not right. So, by default, Johnny, well, yes, no, not default. So you will have the option to compile to an executable that can still read string, eval, and everything else. So you will have the option for compiling your jank project to a dynamic runtime, and that will still link in LLVM. It will still initialize the whole LLVM JIT runtime. You'll still be able to JIT compile things, everything like that. You'll have the whole jank compiler and LLVM JIT runtime along with your application. This is the equivalent of like an Uber jar, where then you when you say java-jar and then your Uber jar, you're spinning up a whole JVM. You have your application code, but you have the whole JVM along with it. So jank already today has the ability to do that. When you AOT compile, you end up building a application with a dynamic runtime, and it still links in LLVM, everything like that. What I'm working on now is the ability to have the static runtime, which allows you to make an executable that doesn't have all of that. And we don't need to like make sure that the application isn't doing those things. We just like the user who's compiling their own jank project, they get to choose. They get to choose. I either want a dynamic runtime or I want a static runtime. And they get to make the choice based on what they want, what their needs are. Check health. So we don't need the health check. Jank static runtime. Where did this go? It was completing with me, for everything else. You still don't understand the difference between static and dynamic runtime, I think. Do you know the difference, Johnny, between an Uber jar and a Graal native image? So a Graal native image is a static runtime. It has everything baked in. It's not actually spinning up a full JVM. It's just taking all the bits that it needs, baking that into an executable that doesn't depend on the JVM. And it no longer has the ability to JIT compile things. You can no longer do runtime reflection. You can no longer do any of that stuff. It's just a static runtime. That is so. That's what we're doing. Jank's AOT compilation is not as it's not as hacky as Graal native image. It's more first class. Graal native images are amazing. Like don't get me wrong, but there are a ton of ways where like Graal native images won't work for your Clojure code if you're using certain patterns, everything like that. Whereas AOT compilation to a static runtime is a first class concept in Jank. So it should work for every normal application. So would that limit Jank users in any way? No. I mean, Jank users have the choice of a dynamic runtime or a static runtime. So we're not limiting Jank users at all. We're empowering them. So we have a lot of linker, like we've finished all the compilation now. We have a lot of linker errors, and main thing we just want to, we want to figure out where they're coming, like what is referencing those things. If both allow exactly the same thing was the dynamic runtime for, they don't allow exactly the same thing. So like, if you have a Graal native image, you can no longer JIT compile code. You can no longer call Clojure Core eval and give it some arbitrary code and have it be JIT compiled. You can no longer do runtime reflection. You can no longer add arbitrary class files to the JIT runtime. None of that stuff exists in a Graal native image. It's all been baked down into just the essential bits to run the executable. Whereas in an Uber jar, you have a whole JVM spun up, and you can do all that stuff. You can JIT compile more stuff. You can load in arbitrary class files. You can do runtime reflection, and so on. That's the dynamic runtime. So if you need to do any of that stuff, you need the dynamic runtime. That's why I asked, but you reply that's not the case. No, I didn't. So eval and similar are not going to work in a static runtime. Yes. I mean, you asked, do we need to check that the user is not using those things? And I said, no, it's up to the user to just decide which they want to do. Like, we don't need to like analyze their program and say, you're using eval here. Instead, just if they try to use eval, we're going to throw. So my interpretation of your question was like, do we need to perform analysis on that? And I said, no, we just let the user choose the thing that they want. Do I want a dynamic runtime? Do I want a static runtime? If you try to do things in the static runtime that you're not able to do, then it will trigger an exception. How small can we go? Well, not that small, probably. Given that we need to bake in so much stuff. We'll see. For the static runtimes with LTO, I'm hoping that we can get something small, but for the dynamic runtime with linking in LLVM, like we're talking 50 megs for a small program like a Hello World or whatever. Because for a dynamic runtime, you can't remove anything. You have no idea what's going to be used later on through JIT compilation, right? So you can do no dead code removal at all, because if that code is later needed when you're JIT compiling something, then you're fucked. But for the static runtime, yes, we can remove all unused code, and we can do whole program LTO. Okay, we need to figure out where all these things are being used. Oh, and Nix? Yeah, I'm on NixOS. Moon Pie Dumplings. Welcome. Hope you're doing great. I see. So this is coming from CPP interop, the library that we use for all of our C++ interop stuff. So we need to not link that, first off. All right, and let's see. Small vector, but where is this coming from? Paths.cpp.o. I don't know what file that is because it's uppercased. So it's definitely not jank code, but it's part of our libjank standalone. Oh, this is gonna be kind of a pain in the ass, isn't it? It's more paths.cpp.o. I wonder. Yeah, so this is in CPP interop. Hmm. That kind of fucks us over, actually. So we have a helper script right now called AR merge, and this script is going to merge all of the static libraries that jank depends on into one static library. This is where we get our libjank standalone. And so one of those static libraries is CPP interop. But for our static runtime static library, we don't actually want CPP interop to be part of that. So I think we're going to need to specifically check for this. What is my cacher here? I need to open up the configured one. So build AR merge. So we have our cacher. This is our AR cache. And then we have all of these object files. I want to run this, but I want to do this on AR cache. So this is just a bunch of object files. Right. So I need to exclude this guy. I can hack this in, but I just wonder how I want to handle this going forward. Unfortunately, there's no great way to combine two object files. To combine two static archives. And it's one of those ridiculous things about the native world, the native build tool chains. And so instead, what you need to do is just unpack both of them if you want to combine two static archives and then pack them back together. But the problem is that static archives and paths, they can have duplicately named files inside of static archives. The whole thing's a mess. And so this script that we have keeps track of all of the object files that go into our static archives that jank depends on. And then finally, as part of one of the last CMake steps, it grabs all those object files and puts them together into the libjank standalone. And so that ends up being our standalone static archive that has not only all of the jank object files, which are all the ones that you're seeing baked into here, but also we have all of these .a.list files. And each of these is, so if we take a look at libclang, each of these is just a file that has a bunch of other .o files in there. And so all these just get concatenated together. And so here's our paths.cvp.o, which is referencing the LLVM stuff that we don't want right now. Yeah, so I think for our error merge script, we're probably going to end up needing like 2 different sets of jobs. We're gonna need jobs to build our dynamic runtime, and then we're gonna need jobs to build our static runtime. So I'm just gonna hack in the exclusion of these. What's a good way to exclude this? So if I'm doing this grep, we can see our, we can see these right here. I think if I just do a grep v of lib, where is it? If I just do a grep v of this, then we go from third-party GC TVA to nanobench. Whereas before we went from, here's nanobench, and then GC dir. So it was in between nanobench and GC dir. Now nanobench and GC dir. Okay. So yeah, that's all we want. I'll just take this and okay, so by saving that, I should have, I'll jump to it here. I should have had this update. Yes, it did. Because CMake's going to pick up that this script has changed, and then it's going to reconfigure. But we're still seeing paths.o in here. Why? Why? Maybe we just need to relink it. Oh, because it's in the phase 1. We have a 2 phase, and the phase 1 is right here. Okay. Yeah, so as I said, we're going to need different sets of these. So we have right now, we have a merge job and a merge phase 2 job. We're going to end up with a merge dynamic runtime and merge dynamic runtime phase 2, and then merge static runtime and merge static runtime phase 2. So rather than 2 sort of commands here, we're going to end up with 4. But for now, I'm just going to hack it into the 2 that we have. So let me delete these again and then try to rebuild. Nice. Okay, now we're no longer getting stuff about the paths .cbp.o, and we're just dealing with compiler native, which is actually jank code. So let me add a Okay. So compiler native, let's take a look. So yeah, what are we referring to in here? Eval wrap expression. On 29 it says. So yeah, this doesn't exist. Let's do... We should probably just have a dedicated error type for that, because there are going to be, I think, a few different, probably a bunch of different places where we're going to want to throw a similar sort of error. Just like, well, we can't do this with a static runtime. And maybe this is used, maybe it's not. So I'm just going to do a maybe unused here. Okay, moving on. So core native, we have compile module. Core native does compile module. So I wonder if this is like what DJ Blue was saying, if this is actually used in core native load module. Yeah, load module is actually the only thing that we're using core native for here. So that means that compile module can just go away. Okay, so in optimize.cpp.o, optimize, oh yeah, bunch of LLVM shit. Let's do this. Also, I forgot this. Okay. So now we have a bunch of undefined references to all of our CPP util use stuff, stuff that we disabled. This is being referred to in IR print. We shouldn't have the need for any of this IR stuff either. So I wonder if it makes sense in the long run to just have like a rather than a dynamic runtime library, static library, and a static runtime, static library. I wonder if it makes sense to have just like a base library that is used by both. And then the dynamic runtime is just additions on top of that. And so in the static runtime case, we just use the base. And it doesn't have things like all the IR stuff and analysis and eval and the LLVM stuff. It's just the runtime. It's not the compiler. Like right now, I mean, with the way that Clojure works, the compiler and runtime are just very much intertwined. That's just the design of Clojure. But yeah, I think to split them up in terms of libraries might make this easier. Doesn't need to change how we're approaching this now, but it might just change the ultimate shape that this takes. For now, I just want to see what pieces I need to tear apart in order to actually get something compiling and linking. Okay, but lots of IR processor, IR instruction, IR print. Yeah, like all this IR stuff. And then we get into analysis stuff. And we have our whole analyze processor. Yeah. I think if we we could possibly restructure the compiler and runtime to separate these things out. I do like the idea of that the more I think about it. Do a quick restroom break. Be right back. Yeah, I think I will do that, but I'm not going to do it right now because I think it would just be too messy. Print, do the same thing. Okay, we still have a lot. What are we looking at? Ref. Undefined reference to var deref constructor. For IR instructions. Okay, but yeah, where's that actually used? Hoist var derefs. Okay. Yeah, so each of these files I think is going to end up making it into a separate static library. And that would overall make Jank's distribution smaller as well, because rather than just like 2 copies of the whole compiler and runtime, where one is like a neutered version of the compiler, instead we'll just have a base runtime library, and then we'll have a compiler library on top of that. And the dynamic runtime will have the base plus the compiler library. The static runtime will just have the base. Dominance. IR builder. Okay, now we're into analysis. So we have local frame is trying to use CPP interop. CPP new is... Okay, these are all of our AST expressions. Their stuff is undefined. And then we also have this disable ABI breaking checks from processor. I don't actually know where we're using this. We're not. So that's being used by something else. It's a transitive use. So all the AST expressions will need to be moved or disabled. And then bunch of analyze processor stuff. The whole analyze processor, which is our whole analyzer. Yeah, okay. So maybe we should go to source CBP, jank, analyze, expr. We have all of these. And do we really want to? This is it's really going to be a pain. All right. Let's, instead of like changing each of those source files, let's just do a do.cbp. Let's just disable them right here. Say, yeah, don't even compile these. This is all runtime stuff, error stuff, util stuff. Cool. All right, now namespace.cbp refers to the analyze processor. Why? Why is namespace? In refer global. This is a bit of a hack. That we're using the analyzer here. No, we have to go through the analyzer for this because we're resolving an arbitrary C++ symbol. It could be anything. It could be a preprocessor define. It could be a function template that needs to be instantiated. Yeah, so we have to go through the whole analyzer. Okay, so that means that we just need to section this off. And so this function returns an error ref. Okay, so this actually forces us now to make a proper error message for proper error type for this static runtime stuff. Let's just do that. How do we want this? So is a runtime error. Static feature disabled. I don't love that name, but we'll stick with it for now. Static feature disabled. Okay, and then so we want error runtime. And then so we want static feature disabled. And this is just going to be just give me a message. Okay. So now we can create those errors. That's error. Yep. And this is refer global. This should not be message. This should be feature. And then here we'll do a format of unsupported feature blah. Wait, no. The blah feature is unsupported in a static runtime. Feature. Oh, whoops. Runtime. Static feature disabled. That's just our default error message for a type. Every single one has one, but for a lot of them, it's not actually ever used. We just want to make sure that we always have something to fall back on. Okay, so I need a source for this, which is why that's failing. So I should just be able to jump here. Read source unknown. Or not. Oh. Source goes there. All right. Yeah, so this is mainly just tearing things apart until we get the smallest sort of static runtime that can actually link. At which point we're just going to see if there are any other issues. If there are no other issues, everything just kind of works, then we need to refactor all the libraries and everything so that way we can actually build this reliably as a separate thing. 197 in s.cpp. froze it. I froze everything. Are we back? We're back. I was wondering why the numbers aren't working, because I had them working before the stream. Let's try to trigger that again. Huh. Oh well. We just get to look at a bunch of zeros at the bottom. Classic. Okay, cool. So undefined reference to load. Sure. Do we still have a fuck ton? Oh, we don't. Look at this. That's the top of it. Oh, we're close. Undefined reference to main. Yeah, okay, fair. File view in highlight. Okay. Highlight. We don't need this. And then a bunch of this stuff. Where is this? C API. This is our initialization. So this whole jank and init stuff. I need to look at what our AOT processor does. We do call jank and init with PCH right now because our AOT processor is assuming the dynamic runtime. But we're going to end up having a... Like jank init with PCH I think will change names to jank init dynamic runtime. And then we'll end up with a jank init static runtime. So let's add that. Let's add a... Oops. Let's add a jank init static. So we're not going to have a PCH data or PCH size. We're not going to worry about initializing our runtime context. And okay, so then what we want to do is pretty much, we want to grab all of this stuff up to here. And my reasoning is like, jank init dynamic should basically do a jank init static and then some more on top. So if we do a jank init static, that initializes our garbage collector. This is our try. We're going to need a catch. Yoink that out. There's our catch, return 1. Here we return 0. Okay. Now all we need to do is call our lovely function right here. That's our argc, argv. Okay. So in the case of jank init, which we're going to rename this to dynamic, and fortunately, I'm okay making a breaking change because because we're still bleeding edge right now. So we'll do a jank init static. We'll give it our argc, we'll give it our argv. We won't worry about anything else except for a function. And the function will do and then this is a char const pointer to pointer argv. There's that. Oh, fuck. We need to capture this, and we can't do that if we just want to give a pointer to a function. C APIs. Okay, so yeah, we can't actually just build on calling jank init static from jank init dynamic. Instead, we just need to have a common so this is going to initialize our locale. It's going to initialize the GC. And then do we want to even? No, we don't. We don't even want to do a try catch in this guy. That will be reserved for down here. So here we'll do a jank init common, and then we'll do a call return with argc argv. All right, yeah, that's our static init. And then for the dynamic, we'll jank init common, then we'll initialize LLVM, and then we'll initialize this, and then okay. That's everything. So we do just have this jank init. Are we just calling that from main? We are. I don't know if I want to keep that. I'd rather just be clear about whether or not it's static or dynamic. Jank init static, conflicting types for jank init static. Okay. So returning int, taking 3 args, Right. So we didn't remove that stuff. And then, yeah, let's remove this while we're here. And so this will be jank init dynamic. And I think that was the false and then null pointer and then 0. Okay. So do we have a short list? It's a little longer now. So our parser is reaching into our analyzer. CAPI is reaching into AOT. That's on 10.16. Register resource. I don't know where that comes from. AOT resource. Okay. But that doesn't exist anymore because we removed it. Okay, we'll add that back in. I think we need AOT resource because that's basically Jank's ability to embed resources into executables, just like how you can embed resources into a Uber jar. That's a pretty handy closure feature that I use pretty often. So I wanted to make sure that we cover it in Jank as well. Okay, so CAPI is referencing Clang dump. Okay, I don't see the reference to that. So parse is referencing the analyzer. We saw that, just didn't want to deal with that yet. Okay, what are we doing with Clang here? Nothing. What are we doing with LLVM here? This in init, yes, but we'll only have init dynamic if and def jank static runtime. Rest of this stuff. Yeah. Okay, so this will be runtime context. Runtime context core gives us a read file. Clang format, okay, fair. And environment, binary version. Okay. So let's take care of Clang format. I just want to Clang format, not compile that. Environment. We need this one. Undefined reference to get clang revision. Yeah, maybe we need to make sure that when we do AOT compilation, that we just hard code a binary version. So we'll do a if and def here, and what about else? I don't know if that's going to be needed. So for now, we'll just throw. We need an include for that. So we have an error system. We need an error runtime for that. Close. Close. Runtime context. Module loader load. 544. Right here. Yeah, load module. Do we need that? Let me jump back here. Core.jank. Load module. No. Oh, load module is called by core native load module. We're going to end up with a different version of it. So what we're going to say is, here it is. Yeah, so if you try to load, we just have to have a manage load function. If we don't, then we give you an error. Okay, so we're referencing the analyze processor from runtime context. Analyze processor, so not here, but where? Here, in analyze string. Okay, so we have our parse, which we know about. CAPI is doing some OStream shit. Construction context. So we don't have any more Clang stuff or LLVM stuff. Wonder if this is because of the includes. Yep, seems like it was. Okay, so environment, we have find program by name, which we are calling. In resource dir, do we need this? Where are we using resource dir? So we use it in the loader. That's the definition. So it's used here. I think this path stuff for the module loader doesn't matter. So I'm going to get rid of that. And then I'm going to get rid of that. So runtime context. LLVM unreachable. That's everything. Oh, it all fits on one screen now. So close, so close, so close. Undefined reference to JIT processor. Okay. Runtime context 49. JIT processor. Okay, but the JIT processor constructor should be present. It's right here. Did I not do that right? Takes an immutable string, ref to const. Jank dit processor. Jank JIT processor. I probably removed this. Yeah. Okay. So the parser, checking if forms are special, and core.cbp read file. Let's do that. Core.cbp. That was on what line? 918. This is not the one. Okay, read file. So this is one where we're just going to say if in def jank else, and if we're going to throw error read file. I think we need to include that. Include jank error runtime. And then those params end up being unused. Fair enough. Okay, so just three more looks like undefined, undefined, and undefined. So in runtime context, we are accessing the destructor of the JIT processor. Fair enough. JIT processor, destructor. Done. And then environment, we access disable blah, blah, blah. Where this must just come in for the includes. And then the last one should just be the parser. Oh, that's a bad miss. There we go, 249. Okay, now it's just the one, which is in the parser. And that is, don't have a line number on that. But we're calling, we're in syntax quote. And we're calling is special. So parse is special. And this guy, proc is special. So we're just not compiling the analyzer. Can we just get away with not compiling the parser? No, because we need to parse meta on startup. We have to have the parser. We could move this into a helper, so it's not part of the analyzer. But it does use this specials map. The specials map actually has pointers to all of these functions. So it would be nice if we had a separate way of knowing if something's a special form. I don't like the idea of maintaining two different data structures for this though. So if we add a new special form, like right now, you just have to add it to this one map and then there you go. But if we add it somewhere else, then you'll also have to add it to the that one that the parser is using. How to handle this? Why do we need to know if it's a special? For qualifying in syntax quoting. Okay, fair enough. Yeah, I think I'll add a I think I'll add my own so I just take a symbol? Object ref? No. So if it's not a symbol, return false. Convert it to a symbol. If the namespace is empty and it's finally or catch, return true, because those are special cases. Otherwise, look inside of specials. And we're just going to initialize specials right here to be a static native set of JTL immutable string specials. And do we want name? Okay, so I think we should just be able to grab all of these and yoink that off. And then here I'm just going to remove all of the make box symbol shit from this. Yeah, that's fine. And then here I'll remove all of those. Oh, let me replace those with a comma. And then I think we don't need any of these. Nice. So those are all of our specials, and then we'll see. Okay. And so when we check is special, we're just going to check this one. This is called form. All right, looks fine. Looks good to me. Okay, and so now we're just missing main. So what that means is we have successfully linked everything except for our main function, which we have disabled because of all this. And we inside of our main, we were referencing a bunch of LLVM stuff as well as analysis stuff and everything like that. So it's understandable that we're going to run into issues, linker issues, probably compilation issues, even if we deal with main. So we're as far as we can go. And we haven't hit any other issues. I think what we can do now to get like a successful actual AOT build of this, we're going to need to build this into a library. Just wondering how we want to do this. I think, well, I need to specify a dash main function for AOT. Yes. Yeah, to start with, you're going to need to specify your own dash main function in jank. In the future, we're going to have an option to where you can skip past all of that and define your own actual like straight up native main function, and then you can you'll be able to initialize the whole jank runtime using the jank init stuff. But that will allow you to write a jank application that that doesn't even initialize the whole garbage collector or anything like that, and just does some straight up C++ stuff. So if you wanted to do some of that stuff first before you jump into the more dynamic garbage collected environment, then you can. And then that opens up the door for like using jank in more constrained environments as well. We'll have to see. There's a bunch of other shit involved in that. But for now, yes, you have to do. So I have an example here in like temp AOT, I think. You have to specify a dash main. Okay, so libjank. I'm going to copy this guy. I said dynamic RT. I should have said jank standalone dynamic static RT. There we go. Okay. So now let me try this. Now if I do a git stash, we'll save everything that we just did. And then we compile again. Let's do 16. Basically what I want to do is I want to try to do an AOT compilation, except I'm going to force linkage to this guy instead. And we should be able to observe a difference in that executable being able to start up, and startup should be faster, and so on. And that should be our proof of concept. So basically we pared everything down, we stripped until we were able to actually build this libjank standalone. And this should have like no need to reference any LLVM stuff in here. So that way, like we already have working AOT compilation to the static runtime. So I'm just going to, like, once I build this, I'll verify that that works. We'll have our sanity case, and then I'll go and I'll change the AOT processor to link to this static RT1. And then I'll use the jank init static instead. And we should be able to make a new executable with the static runtime. Now, of course, we'll still need to actually hook all of this into CMake so that we're always building both of these and do the correct separation. But in terms of hacking this together and getting a working proof of concept, that should be all we need. Miraculous, welcome to the stream. Hope you're doing great. Coreman27, welcome. Hope you're having a good one. Okay, so our AOT processor. So we have why is this the only thing here? Libjank standalone. What did I search for? Huh. Libjank dash standalone. But doesn't it? Oh, it's because the lib is implied. So this is just dash L jank standalone. I do, thank you. How about you? I'm doing great, Corman. I'm having a good day so far. Trying to juggle a few things, doing this AOT related stuff on stream, but have some other performance work I'm trying to get merged, but I have a crash that's only showing up on Mac OS in a release build. I got to dig into that. That's what I was doing this morning. But hard to do that on stream because it's on my Mac. I don't have a streaming setup on the Mac. Plus, I was going to say, I don't know if that'd be fun to watch, but then again, I don't think watching me watching me pare down the entire jank compiler and runtime is necessarily exciting either. Okay, so we should just be able to do, let me open up this temp AOT guy again here. And we're just going to do a hello world here. There we go. So let's do a jank compile. We'll specify the module path as this temp directory, and AOT is the entry point module. So jank's automatically going to look for AOT /dash main. You could SSH into your Mac. I could, but I just don't want to do that. Like I don't like developing in that way. Because I'd have to use like tmux or something like that to be able to handle the multiple windows that I want. I don't like it. I have my window manager set up that I've been using for a long time. That's how I like to do things. Okay, so we have this Ada out. This is the dynamic runtime. And so also we're on a debug build, so everything's going to be 10x slower than it normally would. But we got a super chunky guy, also not stripped. So when we strip this, you know, half the size pretty much, but still very, very large. And again, this is the dynamic runtime. And you know, we're at like 1.3 seconds to run this. So let's try this and see if we can get the static runtime in. And then we're gonna want jank init static false. I think that's it. So I'm going to copy Ada out to Ada out dynamic. Okay. So let's compile again. So this is saying that the C API H it's this. There we go. So yeah, the forward declaration of this symbol, I still had the incorrect signature here. So we stashed all of these changes, which means that like when we look in the C API, we don't even have this jank init static anymore, right? But it is it's baked into this this libjank standalone static RT. Like we have an archive now that has all of those object files in there. So all we need to do is provide the right declaration to say, hey, this symbol exists, and then the linker is gonna piece that all together. NFEJZIC, I have no idea how to pronounce that. Welcome to the stream. I hope you're doing great. Okay, cool. So we're getting a undefined reference to jank vfun and jank var, and also jank load closure core. So vfun and var come from the CodeGen API. So we're gonna make sure that we need to we're going to need to make sure that we link. Okay, so we didn't link to that in our... That's the problem. We didn't link to that in our static lib. NF. All right, I gotcha. I gotcha. Welcome, welcome. May know what you're building. So we're working on the jank programming language. Jank is a dialect of Clojure that's native, and we use LLVM. And if you know anything about Clojure, then that probably answers it. The other thing about jank, which is cool, is that jank is, I would say, based on everything I know, it's the language, it's the language that has the best interop with C++ out of all languages that have interop with C++. That includes D, it includes Swift, and so on. So we have really good C++ interop. Are we doing any escape analysis? Escape analysis is not very viable for most of the time with Clojure because it's such a dynamic language. Yeah, so Sir Elfman, I know what you mean by escape analysis, but to do escape analysis, you need to be able to know which functions are going to capture which values, right? And then with that knowledge, you can then say, okay, this value is not going to be captured, and therefore it could be stack allocated. It doesn't need to be GC allocated. Most of the time in Clojure, because we work interactively, functions can be redefined at any time. And so you're not able to just make an assumption about how a function currently looks, like, oh, this function currently doesn't capture, either of its arguments or either of its parameters. That may be the case right now, but if you generate some code that assumes that, it may end up being broken in 5 minutes when that function is redefined. So there are some compilation targets for Clojure where you're basically saying, like, you're not allowed to redefine things, try to be static, but for the most part, escape analysis is not a very practical application, very practical optimization for Clojure. Maybe during runtime you can do things, maybe, but not that I can see. Oh, cool. Is Clojure in the list family from NF? Yeah. Found escape analysis really good for heavy temporary allocations, for sure. Absolutely. If you like have the language semantics that allow you to be able to do it, then fuck yeah. I would love that. Have I tried using codecs or something like that for jank? Like with what goal? What do you mean, Johnny? What's the goal there? Okay, so I know how to solve these, but we're going to need to pump our stash and then rebuild our static lib in order to have that. But why is this not found? Jank flow Clojure core. This should be found. Ideas, code review, tests, letting them write code. No. Not for writing code. I'm not open to that. I do use LLMs occasionally to help with ideas or to help with Clang interop in particular. I do a lot of work with the Clang AST, and there's no user documentation for that, so it can be helpful to get some like starting code from an LLM for that. But especially since Clang breaks its Clang and LLVM breaks its API every 6 months, it's also really hard to get any code from that actually compiles with the version of Clang that we're using. But yeah, we use like I get Copilot for free, just as like an open source contributor type thing. So we use Copilot on our reviews. Might as well, and that catches some stuff. But I'm far more interested in the human side of coding. But where is this? So this implies that our static runtime static library doesn't have jank load closure core. Yes, that makes sense, actually. It wouldn't because of phase 1 compilation. Okay. So we need to do a couple of steps here to make this proof of concept work. So we need to git stash it's 0 based, right? Yeah. So we're going to apply this. We're going to configure with a release build. And we need to add the CodeGen API into this. I changed that while I was configuring. I want to configure again just to make sure that gets cut. Yeah, Johnny, jank has a contributor policy against AI generated code for external contributors, and currently I'm the only internal contributor. So that's basically everybody else. And I've used Claude for a couple of things that are Clang related. but for the most part, like every line of code has been written by a human. I want to keep it that way. Yeah, I've had Copilot catch some pretty good stuff for me when taking a look at pull requests. There've been some pretty good ones because like I review every pull request that other contributors make, but nobody reviews my pull requests, and so it is nice to. Okay, so we don't need this. And okay, so now we're good. Lib jank standalone. Right. But main. How are we gonna do this? Thinking about, because I'm just hacking around the build system in a somewhat tricksy way. But we'll do this. Let me just make sure that this is the recent one I want. Yep. Okay, so we'll copy this to build libjank standalone static runtime. Overwrite that, kill this, and then I think we could just do a hard reset. And now we'll do a git stash apply for our top. And we'll rebuild. All right, and now we wait. Back to the waiting. The plus side is we're doing this. Hopefully this way allows us to see the results for the proof of concept sooner without having to build the whole thing first. George Hotz had a interesting take on issues of adopting AI software. The eternal slop-timber. Is that a video, DJ Blue, or is that a article? Nice. Thanks for the link. Yeah, I think this is exactly. I have a lot of thoughts on this, which is why I proposed 2 talks for the conj. One is about jank and just focusing on jank's features and everything like that. But the other one was about the other one is about this basically. I don't want to get into it because if I end up giving the talk there, I'd rather it just be like fresh material. But yeah, I'm not the only one with thoughts on this, obviously. I'm grateful to have lived to have a career of 15 years before all of this, though. I got those good development years in where people just wrote code in exchange for money, and the code was something that they took pride in. I do use some AI mostly for my clients since they're asking for it. I prefer to write code myself. I can see how a lot of people would be asking for it. Like they want the supposed speed that comes with it. I mean, we just saw there was the whole bun thing, right, where they replace all of the Zig code with Rust, and then there was just a follow up in the Clojure Slack about that, where someone's like, "Oh yeah, I was reading about that, and I realized like code doesn't matter, you know." And so here I've rewritten my project, which was in Clojure, and now it's in TypeScript, and also now it's in like these other 2 languages. And I don't agree with that. Okay, so this is the problem. We need eval. We need eval stir. Yeah, I'm going to need to think about this one because like I know why this isn't found. Like that's easy enough to fix. We should just have a build core libs Clojure core.o, which we can just link in. But the other one, build core libs Clojure core.o. $1 million lines of Rust is kind of crazy. No? Yeah, it's pretty fucking crazy. How many lines in jank? Like 50, 60,000? Not very much. Yeah, I think like it's, I remember I was talking with one of my mentees. Yeah, I was talking with one of my mentees actually. This was about a year ago about Bun, and he's like, wow, yeah, Bun's like 1 million lines of code, because you know it was 1 million lines of code back then as well, and he said that kind of with like I don't know, a bit of pride or something like that, and I was like, that's not a good thing, you know, like that's, I don't know if Bun, I don't know if Bun needs to be that, you know, that big, and if it is, like, I don't know if I would brag about it. Like there are some things like, you know, Unreal Engine, for example, is like 4 million lines of code, and it just has like, you know, like has the whole editor, and it has the networking stack, and it has like the fucking nanite and lumen and MetaHuman and real-time ray tracing, and just like, oh, there's so much stuff, and it's only 4 times as many lines of C++ as Bun had of code for a JavaScript runtime. And so I asked the mentee, I was like, how big do you think jank is? And he's like, oh, I know, I've looked at it. He's like, it's like 50,000. I think then maybe we were like 40,000. And this was about a year and a half ago. And because it was before I had done the real C++ interop work. And I was like, yeah, it's like 40,000 lines. And he's like, that's really small. I was like, yeah. And I was like, and it's going to stay that small. I said, when I do this, you know, seamless C++ interop to give jank unprecedented C++ interop compared to any language, like it's not going to take more than 5,000 lines of code. And so we put a bet down that it wouldn't take more than 5,000 lines of code, and it didn't. So unprecedented C++ interop under 5,000 lines. But the problem is when you AI generate code, it's just not efficiently written, and so, and that's not to say that all the Bun stuff was AI generated from the start, but this problem just gets worse and worse and worse. So I'm always reminded of this quote. I apologize for the long letter. I didn't have time to write a short one. Hey, I've said that. Yeah, that's a great quote. I don't know if we can progress with this proof of concept, and I'm going to have to chew on how to handle this. Because that's odd. It's trying to compile the object file instead of just linking it in. Okay, but either way, we have a problem. And the problem is, I'll show you by doing a compile module. target. Yeah. So here's the problem. When jank has metadata and we AOT compile, we end up writing that metadata as an Eden string like this. So here's like, jank source and then file and then start and offset and arglis. This is some metadata for a function. And we write it as a string of Eden, of closure data, right? And then we do a jank eval on that. And this is necessary to eval as opposed to just parse, because metadata can have things like functions in it, and those functions need to be evaluated. And so we either need to be able to eval this stuff, or we need to not eval it. And in a static runtime, we can't eval it. So I don't know if we want to like fake eval, as in, yeah, we'll read this, but when we hit a function or something like that, we're just not going to like JIT compile a function. And so we'll still be able to parse it. Or another option is we just strip out all this meta, which I'm guessing might be what we want to do instead. So when you're compiling for a static runtime, we just strip out all of this metadata. But I don't know. I don't know what I want to do here yet. I think stripping out metadata would be easier, but I think it is a smaller binary if you remove it. But I think that semantically, I don't know if we can actually rely on, I don't know if that's going to break people's applications if we just remove all the meta. That's the problem. So we can't actually eval, but we have to deal with this meta. Can we switch to read string for static? Yes. I would be interested to know what happens in a Graal native image when you have meta on your vars, because the meta for all those vars needs to be evaluated, but you're not able to JIT compile functions. So what does a native image do? Hey Berg, we're making a programming language called jank. Jank is a dialect of Clojure. Clojure is a modern practical Lisp. Jank is a dialect of Clojure that is native on LLVM, and it has unprecedented C++ interop. Best C++ interop in the world, as far as I know. Better than D, better than Swift. And right now we're trying to tackle AOT compilation or at least one hairy facet of AOT compilation. I assume for Babashka maybe still be evaled. Well, sure for Babashka, but that's with small closure interpreter. But I wonder, just like a normal closure uberjar, if you just AOT compile it, then what do you get? Johnny, why did you originally make the choice to reread meta? Yeah. So if we were to generate the code that would be required to create a map, intern a keyword, create another map, intern another keyword, dynamically allocate a string, intern another keyword, and so on, it would just be far too much generated code. And so that would take longer to JIT compile, and it'd just be a lot more bloat. And so for any sort of literals, complex literals like this, I just do a read string instead. Technically now I do an eval because that's the correct way to do it, but historically it was just a read string. Yeah, so we could do we could change our code gen here to just do a code gen API, but I don't think we have a read string. No, we don't. So I'd have to... maybe doing some snapshotting? Yeah, I don't know. So I'll add a eval. I'll add a jank readster. Oh wait, we already have a forcefully read string. Okay, so yeah, we could try this. We can try this again. I think we should probably just default to doing a readster instead of an eval. And then we should just add a separate optimization option, because I know that Clojure has this as well. It has a flag for you to strip meta. And so we can add a separate optimization option to just strip meta. And then that way you don't even need to do the read, the readster. But by default, it's like, okay, we'll try to meet you in the middle. We'll keep the meta that you have. If you have any sort of functions or whatever, they're just going to be read as a string though. That's probably the fair approach. Catrocitus, is there C interop with jank? There's C++ interop. So there's as good of C interop as C++ has, which is pretty good. Okay, so we want to yoink. So yeah, jank hooks right into Klang's AST to be able to interop with C++, and we JIT compile C++ code. So right in the middle of your jank code, you can just include some C++ headers, and then you can start accessing the C++ values, throw and catch C++ exceptions, instantiate C++ templates, and then when you have like local values that are C++ values, their destructors will be called at the end of the scope, just like they would be in C++. And all of that fits within like a dynamically typed Lisp. Okay, so we're going to grab this guy. And then we're going to need to go to our CVP processor, and eval stir is going to need to be read stir. Do you perform any extra analysis of the interop calls, or do you just emit C++ code and let the last phase C++ to LVMire do the work? We don't blindly emit C++ code. We do full overload resolution, including argument dependent lookup, friend functions, operator overloads, built-in functions, implicit conversions, and everything. Like Jank's analyzer verifies that what you're writing is valid C++. So all of that is validated during analysis. By the time we're generating C++ code, we know it's right. How? Yeah. That's the special sauce. But it boils down to hooking into Klang's AST and also hooking into the Klang JIT compiler and combining those two. So Klang has the ability to JIT compile code and then give you like a partial translation unit as a result. And then you can use that. You can work on the AST from there as well. But there's a ton of work that goes into verifying that that all of the weird edge cases of C++ have been met. This must be the hardest thing you've done so far, right? Yeah. Yeah, but that's what makes jank feel amazing, right? That's what makes jank feel great. So like, let's take a look at, for example, this code was just written recently by one of our community members, Kyle, to do it's a benchmarking tool set. So this is all jank code, but it uses a C++ library. So we have, let's do jank perf core. We'll take a look at what's up. So here, when we're defining our jank namespace, jank perf core, we can require some other jank namespaces, but we also just include a C++ header. So this is .h, but it's actually a C++ header. And so that gets JIT compiled, right? And then we actually have a way to do inline C++ as well. And so here we want to be able to have an easy way to turn an arbitrary jank object into a function. And so there's a to-do saying like, is there a way that we could do this in jank better? But if there isn't right now, then you can easily just define a C++ function that takes in a jank object and returns, in this case, a lambda. And then this function is called make callable, right? So you'll see here, we're just calling that function right here. Like this is jank code, but it's just reaching into C++, jank perf core make callable, which is this jank perf core make callable, and we're just calling that. And so similarly, like this whole nanobench stuff, that's all C++ that comes from this nanobench header that we brought in. And then all of these like dot sum, dot minimum, like we're calling member functions on these values. So this is all just C++ interop. And the whole point is like it blends together. So like some of it is dynamically typed and some of it is statically typed, and jank, whenever you do any sort of interop stuff, jank verifies that everything you're doing is correct. Like here, when we're calling a member function, we're passing it this elapsed measure. Like we have to know what elapsed measure is. And so that's actually a def up here of this. Like this is a C++ value that we've grabbed out from nanobench and put it into a top level def. And so we'll do full overload resolution on all this stuff as well. This is a fun one here as well, because result is this like opaque box of a pointer to a nanobench result. So we unbox that, we grab it out, and then we can actually capture that. So this gets, here we have a lambda function, this result, which is a like a native pointer to some native value, just gets implicitly captured in this, and that works totally fine. You don't need to like rebox it or anything like that, even though you're crossing a function boundary to get into this lambda here. So this is only the start. Like we can go even better, but this is still like nobody does C++ interop like this. Okay, so let me get rid of this, and then CodeGen API. So eval readster. Eval read. Is this the jank? I don't know how many janks there are, but this is jank. Xenobus, welcome. In Java, this is so much easier to do. Yeah. Well, Java is a much simpler language, and it's also built on the JVM, which operates at the level of Java. So you're able to, like any language that's on the JVM is able to do Java stuff pretty much. But yeah, people don't do this with C++ because it's just fucking tough. Damn, dude, cool work. Jank blog's always been fun to read. Nice. I'm glad you enjoy it. I appreciate the kind words. I like writing those posts. And I like working on Jank. Most of the time. Not all the time. Okay, I think we're close to, I mean, I don't know. Maybe we're close to a proof of concept here. Kind of multiple layers deep in this nacho though. Like, I don't know, that expression didn't quite work out the way I wanted it to, but okay, so what were we doing? Probably one of these. Oh, please. Please. Undefined reference to eval stir. Why are you doing eval stir? Let me clear that. How much time have you invested in interop? How did you learn how to do the C++ analysis with Clang? Well, I did. Oh, nice. It's gone. So do we just have this? Perfect. That's exactly what I was hoping we would hit. Johnny, so I originally did interop in Q2, like before Q2 of last year. We had oh, this will be fun. Let me put this on. So we had so how to build a closure dialect YouTube. I'll show you what Jank's interop used to look like. So interop. Hello everyone. Oh shush. Interop. All right. Quiet now, older Jay. Okay, so Jank's interop used to look like this. Nothing new. Seen that one? Well, it's technically older. Yeah, technically younger. Yeah, that's a good point, DJ Blue. That's kind of a mind-blowing point. But so we used to just do this native raw, which is like, and then there was this special __ value where you can then, and then we had this special interop syntax here that looks kind of like closure set syntax. So you're grabbing this call here, and this would basically just blindly plug in values into the interop. And so this was like minimum like minimum effort interop, where we didn't need to do any analysis to know if this was valid C++ code. We just trusted you to make sure that it was valid. And also, if ever you wanted to get something out of this, you had to put it in this boxed value. So in Q2 of last year, I focused on like, okay, how can I do this like Clojure does it, you know? And so let's take a look. This was, so I quit my job and then I did error reporting and then starting on seamless interop. And so this was the goal. And so I was like, okay, so let's start with just being able to do things like, can I reach in and grab values, you know? And so here, if you just include standard string, and then you have like a syntax for being able to say, okay, standard string end position, which is this C++ value that is a -1. It's actually not, I mean, it's depending on if it's unsigned or signed, but since we're turning it into a signed integer, it ends up being -1, but it's actually an unsigned thing. So I started really simply here by just being able to like, can I resolve these, can I resolve these names into something useful? And so, similarly here, like, okay, so what if we already had the ability to like JIT compile this, this C++. So what if I, define a struct and then I create an instance of that struct, and then I try to access a value of that, now, so this is showing like I have the ability to check, is this value implicitly convertible to a jank object? And that's like this whole like template instantiation that you need to do in order to check if a trait is successfully instantiated. And then I built on like, okay, let's do constructors and let's do casting between types, and then I think this just goes into LLVMIR. But so yeah, I started on this Q2 of last year, and I didn't know when I started, Johnny, if it was even gonna like work out. But by the end of Q2, I think that was here, I had a post like, okay, jank is C++. Like this is the real deal. Now this is a stack allocated, integer, and then here's C++ new operator, and complex type constructors. Let's see, streams, actually using like operator overload, including like complex libraries like this JSON library, and then just being able to like to reach right in, call member functions, everything like that. So I had all this done basically in a quarter, which is 3 months. 3 months where I was just focusing on this. And then this was like, it worked, but it was still really rough. It was easy to find, a bunch of different things that didn't work. And so it's been over a year since then. And I've been working on other stuff, but I've also done a ton of work just polishing the interop and handling all of the different crazy cases. So I was just looking into a crazy case this morning that jank doesn't handle well, that I probably have open right here. Yeah. So this is a crazy case where you can define a friend function inside of a struct or a class. And so here this function is called bar, but because it's a friend function, it doesn't actually exist inside of the struct. So if you want to access this, it's not meow foo bar, it's actually in the outer namespace. And so the function is called meow bar. However, you can't access this function. It's impossible to access this function by calling it meow bar. Instead, you have to access this function using argument dependent lookup. This is going to blow your guys' mind. I'm going to show you this. I have a C++ file that demonstrates exactly how this works. So let me delete this. So here's the same thing just written in C++, right? So we have a namespace meow, we have a struct foo, and then we have a friend function inside. And inside of main, we create a meow foo f. Now, if I want to call bar, I cannot do this meow bar because it ends up saying like, oh, there's no bar inside of meow. I'm like, okay, meow foo bar. Nope, there's no bar inside of foo. So then the question is like, okay, so where the fuck is bar, right? If it's not inside of foo and it's not inside of meow, well, where is it? Well, the answer is it is inside of meow, but you can't get there by qualifying it with meow. Instead, you have to get there by not qualifying it and then passing in a foo. And this uses argument dependent lookup, which is called ADL in C++, which adjusts the namespace that you're looking up a function in based on the namespaces of the arguments that are provided to the function. And so in this case, the only way to call bar is to have an unqualified bar where you pass in a foo. Now, if we were to do something like this where bar doesn't take a parameter, there's no way I can call this. There's no way I can call this because every way it ends up being an error. And so in this case, if it didn't take a parameter, then you would have to forward declare it outside like this. And so this basically, it just like explicitly introduces it into the namespace scope. So that way you can call it. But in that point, in that case, there's no point in having it be a friend of foo. So the way that this actually works in practice is if you have a friend function that's defined inline like this, it takes in an instance of whatever struct, or class you're in, and then you use argument dependent lookup. So you're all thinking like, what the fuck, right? So in jank, we don't handle this right now. And so we handle it in the analyzer. And so if you try to call bar here, we're gonna detect this. But when we generate the C++ code for this, we're gonna qualify bar because by default, we qualify all symbols. And so just because like that way things aren't ambiguous. And so we're gonna generate a call like this, which should be right. It should be right, but this is not actually valid. And so I was just looking into this morning because there's a case with like a C++ standard library iterators that do this sort of pattern, and then jank ends up generating C++ code that's not valid. And so we need to detect like, okay, is this a friend function? And is this friend function defined inline? And in that case, when we generate its name, we can't actually qualify the name. We have to use the unqualified name so we can rely on argument dependent lookup. So this is just one example. There are so many crazy examples that I have had to work through the past year or so. And each one makes jank, more and more robust when it comes to being able to handle like arbitrary C++ libraries that you could throw at it. But yeah, this is the sort of stuff that you have to do. Now, fortunately, it helps to have a really good understanding of C++, so you can reason through this sort of stuff. And like in a past life, back when I was doing C++ game engine dev, I was the C++ guy. So it helps. All of those reps end up helping. But yeah, this is something that I still need to sort out for jank, and it's gonna be some more detection for when we're generating calls. Is it a friend function? And Do we need to use argument dependent lookup here? I froze it. Sorry for the freezing. We back yet? We're not back. Now we're back. Sorry for the freezing. Is there a game engine in Jake already? Hey, Kui man. Hope you're doing great, man. There is a game engine in Jank now. I can't show it very easily. There's a video on the Jank Slack channel that somebody's shared. But yeah, there's a networked game engine in Jank using OpenGL that has Quake-like strafing, and Cameron is the guy who's working on this. Is also working, last I saw, on a level editor. That's also, the whole thing's just written in Jank. So it's happening. We're getting there. This has to be why languages use C, FFI instead of C++. Yeah. Yeah. Yep. Pretty much. Pretty much. Okay, so we're so close to being able to link all this together, but we need to be able to get Clojure core linked in there. I might have to abandon COJRS after hearing all this. Surely Rust is much more sane. Well, that's why I was asking, like, what's your interop story like? Because if you want to have like Clojure style interop, you're going to need to hook into a Rust compiler as a library. So that way you can say like, okay, does this function exist? Can I call this function with these argument types? But with Rust, you're going to need to not just match types, you're going to also need to deal with lifetime issues. And I don't know how the borrow checker would have to deal with like JIT compilation. I don't know. This is why Jank is not in Rust. If Rust had supported like a viable JIT compiler and compiler as a library 3 years ago when I started on Jank again, I would have done it in Rust. Jank would have been a native Clojure with seamless Rust interop instead. But when I looked, it just wasn't viable. And I imagine that I would be surprised if today it is viable. I hope that eventually it will be, but I don't think we're there yet. Okay, so we just have this last linker error. Where are we adding all of our object files? Here. Right here. So I want to build core libs closure core. Oh. Hey, Zombie Foo, welcome to the stream. Hope you're doing great. Also, congrats. Congrats on being number 300. We've hit our goal. We're done. Yeah, Johnny, if you just do cinterop, then you don't need to worry about all this shit. But then you don't get to, like, but then you're not really like Clojure for Rust. You're just a native Clojure with cinterop that's in Rust, which is cool. Like, there's nothing wrong with that. But the thing about Clojure is Clojure always has seamless interop with its host language. Clojure with Java, no problem. Clojure script with JavaScript, no problem. Clojure CLR with whatever, on the CLR, like C#, no problem. F#, no problem. I think this is where LLMs might give some direction. Yeah, I mean, it's up to you. Like, ultimately, if you want your language to be created by an LLM, there have been a few different Clojure dialects that have spun up recently that are all LLM created. Okay, cool. So we got that now, but we have undefined reference to Clojure core native compile, Clojure core native eval, and then this eval stir thing. Okay, you know what? I'm just going to take this code gen. Fuck. Why? Oh, fuck. That makes sense. Clojure core itself is using eval stir. Core jank 4865. Okay, so can we take a moment right now and appreciate the fact that we have an undefined reference and the linker gives us the line number in the jank source code. This is because of DJ Blue and his work that we can generate this source information. So I'm able to just jump to 4865 and see right here how we're referencing core native compile. Shout out DJ Blue. Badass. I believe it would be much simpler if Rust didn't have macros. Yeah. I don't know. I don't know if macros are going to matter too much. I imagine the lifetime shit is going to be the biggest issue. That's just my guess. Yeah, I don't know. If we make jank code gen API, if we make this do this, whoops, make that do that. That's that. And then core native. Compile. And eval. Yeah, I don't know if I'm gonna be able to hack this together and get it and get that proof of concept working without actually revisiting and going through more correctly. I was hoping I could just keep hacking to get this working, but I'm running up against the edge of my patience, and also the end of my water. Okay, so right, okay. So this is CodeGen API. Find build name api.cpp.o. Here's our CodeGen API. So I'm just going to link that guy in as well. And then also, I'm going to link in core native.cpp. Okay, so this is going to fail. That's fine. Here are our new things that we're linking in, and then we end up with just with a crash. Scope exit. Build executable. This is at, what's our scope exit? Oh. Are we cleaning up all of these? Yeah, we are. That's dumb. It's dumb, but fine. I can work around it. However, we made it to the cleanup, which means, did we actually get an executable from that? We did. Oh, nice. And it's tiny compared to what the other one was. Oh, nice. Okay, so let's try. Cool. So yeah, we are able to get a binary out now. Let me actually, before I strip that. And turning a namespace. Yeah, hard to say. It's too hacked together to be able to properly debug it now, because the sources I have here don't actually match the sources that are in the static lib that we linked in. But so I'll leave that here. But the nice thing is, if we compare the let me strip both and then show both. So it's literally 10x the size for the dynamic runtime. And that's good. That's good news that we know that the static runtime is going to be significantly smaller. So note that this is without any sort of like tree shaking, link time optimization, anything like that. This is just like, if we take the same exact object files and then we link them in without linking LLVM. So if we take a look at this, oh, this is actually linked to LLVM still. That's annoying, because we are probably doing that right here. Yeah. Okay, so we're actually linking to these right here, which kind of defeats the purpose. But it's dynamically linking, so it's not going to affect the size. But all that code that we removed, disabled, mainly the whole compiler. You know, we left the runtime, removed the whole compiler. We end up removing a huge chunk of code. So that's good. Bodes well. I think with LTO, like, obviously we're just doing a hello world. Like, we still need to spin up, like, we need most of the runtime, because you got to be able to intern keywords and namespaces and have all these different object types and everything like that. But I imagine we're going to be able to trim this down even more, which I like. I don't know how big a Graal native image is for something like a Hello World, but I think we should be competitive with that by the end of the day. All right, I will wrap this up. I hacked in a whole bunch of stuff, so there's a I did this just for the like, because I wanted to get something that worked before I called it today. But we'll leave it here. I'm glad that we get to see the size, but like the size difference, and that's promising. But yeah, there's a ton that I need to do to actually like properly separate these into their different libraries, so that way we can like reasonably develop with these two different runtimes, and have me stay sane. I'm pleased with what I see though. Seems promising. I had fun hanging out with all of you today. Appreciate all the new folks on the stream. I do this once a week at the same time every Wednesday, so hopefully I'll catch you next time. All right, adios.